Let's talk about something you feel every single day. You feel it in a car, an elevator, even just jumping in the air. We're going to dive in and actually measure the world in motion and really unpack the science of acceleration. You know that feeling, right? You get in an elevator, the doors close, it starts to go up, and whoosh, there's that lurch in your stomach, right? Or that kind of floaty feeling when it gets to the top and stops. What is that? Well, that feeling is exactly what we're talking about. That feeling is acceleration. And the key thing to get here is that it's all about change. It's not about speed. You know, a car driving at a perfectly steady 60 miles an hour has zero acceleration. But the moment you hit the gas or slam on the brakes or even just take a sharp turn, boom, that's acceleration. Okay, and this is a really important distinction to make. Acceleration is not the same thing as force. Think about that elevator again. The force is the cause. It's the floor pushing up on your feet. The acceleration is the effect. That's the lurch you feel. One's the push, the other is the result of that push.
So how do we measure this stuff? Well, and this is the best part. You don't need some fancy high-tech lab. Your everyday world, your house, the park, a car ride, that's the only laboratory you're going to need. And that's really the whole point. The goal here isn't just to have you learn a bunch of facts. It's to put you in the driver's seat, to have you work through the real problems and make these discoveries for yourself.
All right, so let's get practical. Let's try a hands-on experiment. And this one is wonderfully simple. Something you can do right now with just a ball and a timer. It's called the ball toss. So here's how it works. First, you just toss the ball straight up in the air and measure how high it goes. Step 2, you time the whole trip, from the moment it leaves your hand to the moment you catch it. And that's it. With those two numbers, you can use a simple formula to actually calculate the acceleration from gravity. It's real physics, right in your backyard.
And here is the formula that makes it all work. Now, don't let the symbols scare you. It's actually really simple. The A is just the acceleration we're looking for. That delta x is the height you measured, and the delta t is the time you recorded. See? Just two simple measurements, and you're calculating a fundamental constant of the universe. Pretty cool.
Okay, so that's the low-tech way. But what if I told you that you are almost certainly carrying a super sophisticated physics lab with you at this very moment? That's right, your smartphone has a tiny little device in it called an accelerometer.
So how do you use it? Well, there are all these amazing apps out there that can tap into that sensor. They can basically turn your phone into a powerful data collection device that literally graphs the forces acting on it in real time.
Okay, so let's do a little thought experiment. We all know gravity is constantly pulling things down, making them accelerate. So if you take your phone and you drop it, what do you think that little accelerometer inside is going to measure? I mean, the logical answer is the acceleration of gravity, right? Well, get ready for a bit of a mind bender. It turns out, while your phone is in freefall, the accelerometer reading drops to 0. Nothing. So what's going on? It's because the accelerometer doesn't actually measure gravity. It measures the forces pushing on it. While it's falling, the phone is basically weightless, kind of like an astronaut in orbit. There's no force pushing on the sensor, so it reads 0. It's measuring the felt acceleration, not the constant pull of gravity. Wild, right? So, now you have the tools. You've got a simple, low-tech method, and you've got a powerful, high-tech one right in your hand. And you understand that crucial difference between what's happening and what a sensor actually feels. With all that, the possibilities for your own experiments are literally everywhere. I mean, what can you measure? You can take your phone on that elevator and actually see that lurch graphed out on your screen. You can measure the g-forces you pull doing a jumping jack. You can track the acceleration of a car as it pulls away from a stoplight, or even measure the forces on a swing at the playground. The world is just full of data, and it's all just waiting for you. So, we've walked through the what, the why, and the how. You've seen the science, and you've got the tools literally sitting in your pocket. So I guess the only question left to ask you is a simple one. What are you going to measure first?